Right, the point A has position vector 3i minus 7j. Now, I could write it like this. I could say that r of A, because r is the symbol sometimes you use to denote a position vector, equals 3i minus 7j. Now I've drawn lines underneath my I, j and my r to denote them as vectors. Now what does this mean though? Well, I means in the x direction and j means in the y direction. So what that's really telling us is that, and the position vector r means the vector that starts at the origin and that goes to the point A. So what it's really telling us is that the point A is the point 3 minus 7, which will be something around there. So that's A, and that's the point 3 minus 7, and if I want to draw it as a vector, I draw it like that. Okay, and then I'll put an arrow on the end, and I can write that vector as 3i minus 7j, or another way of writing it is as a column vector like that, exactly the same. Okay. Now the point B has position vector 8i plus 3j, so I can write that as RB equals 8i plus 3j, and I could write it as a column vector 8, 3, and what it means is that the point B is the point 8, 3. So 8, 3 is going to be about somewhere about like that. So that's the point B. It's the point 8, 3, and the vector, the position vector, goes from the origin to the point B there. Okay. So that's what it all means. Now part A, it wants us to find the vector A, B. So in other words, the vector that starts at A and that goes to B. So what it's asking for is this vector here from A to B. A, B. Okay. And very simple to find this. We just do position vector of B minus the position vector of A, and I could write it with the i's and the j's. It's normally a bit quicker, and I prefer to write it as a column vector. So 8, 3 minus 3 minus 7, and all we do is subtract the numbers at the top. So 8 minus 3 is 5, and the numbers at the bottom, 3 minus minus 7 is 10. And you could actually leave it like that, or if you want to write it in the way they've written the question, then it's going to be 5i plus 10j, and that's the vector AB, which is the vector that goes from A to B. And remember, you get it by just subtracting position vector for A from the position vector for B. Now part B wants us to find this thing. Now remember, these two lines on either side of the vector mean what we want is the magnitude or the length of the line representing the vector. So it's the magnitude of AB. So how do we find the length of this line AB? Well, using Pythagoras is the answer. We know that AB, and I'll draw it again, or I'll sketch it again. This is the vector AB. Okay, it's the vector that goes from A to B. It's the vector AB, and we know that it's 5i plus 10j. What that means is we know that it's 5 in the x direction and 10 in the y direction. So we know it's 5, 10, like that. So to find the magnitude of it, we just have to use Pythagoras. So it's going to be the square root of 5 squared, which is 25, plus 10 squared, which is 100. So it's the square root of 125, and I think it wants it left as a surd, doesn't it? Give your answer as a simplified surd, yes. So we're going to have to simplify this. Well, 125, think of a square number that goes into 125. 25 does. 25 times 5 equals root 25 is 5. So the final answer is 5 root 5.